Welcome to Math TV with Professor V. This is video lecture for college algebra on section 1.5, solving inequalities. And when we're going to be working on solving the inequalities in this lesson, we're going to be writing our answers in both set builder notation with inequality signs as well as interval notation. So just a quick recap. A closed interval is denoted by using brackets around the values a and b, and that closed interval consists of all real numbers x for which x is greater than or equal to a and less than or equal to b. So this is the inequality equivalent of this notation. This is interval notation, and graphically you have a couple options for how to represent it. Back in my day, we did open and closed circles. So since this is a closed interval and we're including both endpoints A and B, you would put closed circles there. Now some of the new age kids, they put like brackets on A and B, but I wasn't introduced to that in my time, so I'm not doing it. And then an open interval denoted by still AB, but you notice how this time there's parentheses. Okay, so that consists of all real numbers x for which x is strictly greater than a and less than b. So what that means is the endpoints are not included in this interval, a and b, but everything else in between is. You can tell that from the inequality because it doesn't have the or equal to sign, right? That's missing. So what does that mean? If you go to graph it, now you have these open circles at a and b, and you include everything in between. All right. If you have never seen interval notation and you want like a little recap, then I'll link a video here. And as a note, when you're writing infinity and negative infinity using interval notation, you always use parentheses next to it. I just think of it like infinity is not some value that you could just bubble in on the number line. So it makes sense. You would put parentheses on it. It can't be contained. Okay. Couple things to keep in mind when you're solving inequalities. You can add or subtract the same quantity from both sides and the inequality is preserved. So basically, if you start off with a is less than b, then a plus c is less than b plus c. Cool, just like equations. However, things get a little more funky with multiplication. So if you start off with the inequality a is less than b, then if you multiply both sides by a positive number, everything stays the same. A times c is less than b times c. If you multiply or divide by a negative number, you have to reverse the direction of the inequality sign. A times c is greater than b times c if c is negative. And this is not just some arbitrary rule. Think about it. If I were to ask you what's bigger, 2 or 100? 100, right? So 2 is less than 100. Now, if I make both those quantities negative, -2, -100, now which one's bigger? -2, right? That's just because negative numbers get smaller when you go to the left, so the direction switches. Okay? Good. So here's, again, the reminder. Switch that inequality sign when you multiply or divide by a negative number. Don't forget, don't forget. So let's go through some examples. We're going to solve inequalities here, and then the directions are asking us to write our answer in interval notation and set builder notation and graph the solution set. All right, so first one, example 1a. 8 minus 4 times the quantity 2 minus x is less than or equal to -2x. So to start, I would distribute that -4. So we've got 8 minus 8 plus 4x is less than or equal to -2x. And then the 8's on the left cancel out, don't they? So I just have 4x is less than or equal to -2x. If I add 2x to both sides, now we have 6x is less than or equal to 0. Don't get nervous. I can divide both sides by 6. What's 0 divided by 6? 0, right? You can have 0 in the numerator divided by a non-zero number. It's 0. Okay, so basically that's our answer in set builder notation. The proper way to put it all together is you would say my solution set declare your variable. In this case, it's x, and then you draw a vertical line. When you read it out loud, you say such that, and then you just plop your little inequality, okay, right there. So that's set builder. Set builder. Do you want me to label it so you remember? Okay, here's set builder. Now it also asked for interval notation, and we're going to graph it. I'm going to tell you let's graph it first because it's going to help us visualize how to write our answer in interval notation. It will. So x is less than or equal to 0. Here's your number line. I always tell my class, don't get carried away labeling all these values on your number line. There's only one number that's important in this problem, 0. X is less than or equal to 0. So closed circle. Less than or equal to means I'm going to shade to the left and include that arrow. That's the graph. Okay, now from here, let's write the answer in interval notation. When you write interval notation, it has to be read from left to right, just the way you would read the solution on the number line, which is why I like graphing first. So if you were to look at the number line here, okay, the start of your interval is going to be the smallest solution that you see on your number line, the smallest value that x can be. Well, it goes forever to the left, so the smallest value is going to be negative infinity. So remember, we always put parentheses on positive or negative infinity. And then go to the right. What's the largest value in our solution set? It's 0. And since there's a closed circle, I'm going to put a bracket. And that's my answer in interval notation. So your brain should work on getting fluent in reading all three versions of the answer: the set builder notation, the graph, or the interval notation, and understand that they're all the same. Okay? Oh, also, yeah, don't freak out. No flipping necessary here. I just added a 2x to both sides. So addition, subtraction, you don't have to flip any inequalities, only a multiplication, division. All right, let's look at example B. This time we have a compound inequality. So I'm trying to isolate x in the middle. Whatever I do to one part, I have to do to the other two parts. So if I'm trying to get, let me rewrite it maybe so it's not so squished. -1 less than 3x plus 2 over 2 less than 4. If I'm trying to get x by itself in the middle, I'm going to multiply everything by 2. Okay. And now I'll have -2 is less than 3x plus 2 is less than 8, like that. Good. Keep peeling away. So I'm going to subtract 2 next, but I have to do that everywhere. So now we have -4 is less than 3x is less than 6. And then last thing, to get x by itself, you would divide by 3. So we've got x less than 2 and greater than -4/3. Okay, so to write this in set builder notation, there's not a lot to do. You just write your little curly braces and then x such that, and then copy down the inequality. -4/3 is less than x and less than 2. So there's set builder. Now, before we do interval notation, let's graph. So here's my number line. Again, please don't get carried away writing tons and tons of numbers. All I'm interested in is what's going on at -4/3 and 2. Notice if you just look at the inequality, x is between those numbers. That's exactly the way I'm going to shade it in. And since this is a strict inequality, meaning x is greater than -4/3, it doesn't say greater than or equal to, then we have open circles at -4/3 as well as 2. This is an open interval. Okay. Now, using the graph, can you figure out how to write the answer in interval notation? So reading from left to right, the smallest value that's in our solution set is -4/3. Since we can't include -4/3, we put parentheses on it. Up until 2. Very good, with parentheses as well. And that's it. That's the answer. You can see like interval notation's a lot more compact, concise. You'll use it more and more as you move along in your math career. Oh, yes. Okay, we've got another compound inequality for you. -3 is less than or equal to 3 minus 2x is less than or equal to 9. So same idea. Let's get that x by itself in the middle. So to start off, I'm going to subtract 3 from everybody. So now we have -6 less than or equal to -2x less than or equal to +6. Next, I'm going to divide through by -2, but be careful. In doing so, now I have to flip the direction of the inequality. So I have 3 is greater than or equal to x is greater than or equal to -3. Did you catch that? Those are my eyes, my surprised eyes checking to make sure you caught it. Okay, and we're done. This is isolated. This is our solution. It might look a little weird. So if I were to put it in set builder notation, I'd probably write -3 is less than or equal to x is less than or equal to +3, just because most brains like it better that way. Let's graph it. This time, notice these inequality signs, they're inclusive. So I'm going to have closed circles at 3 and -3. And then I'm still shading in between though, right? X is between those numbers. And then when you write it in interval notation to show that you're including the endpoints this time, we're going to use brackets at both -3 and 3. All right. How was that one? Are they getting a little bit easier? Good. Got a couple more. Let's look here. Example D. X times 9x minus 5 is less than or equal to 3x minus 1 quantity squared. All right, so let's start multiplying everything out. Distributing that x here, that's going to be 9x squared minus 5x is less than or equal to, remember, it's 3x minus 1, the quantity squared. So when you square a binomial, you should have 9x squared minus 6x. Don't forget that minus 6x plus 1. Good, you didn't forget, right? No. Okay, 9x squared will cancel. Bam, bam, love it. And then now we're left with -5x is less than or equal to -6x plus 1. All I need to do is add 6x to both sides. Check this out. -5x plus 6x, that gives me 1x. Things just fell into place much more quickly than I expected with this cute little problem. Okay, so set builder notation, x such that x is less than or equal to 1. Number line time. Here's 1. Closed circle. Which way do I shade? Left or right? To the left, to the left. Yes, Beyonce knew. Okay, and then in interval notation, we'll have from -infinity to 1. Bracket or parentheses? Bracket, yes, fabulous. Okay, I feel like you guys are pretty professional at this point. Shall we enter you as a mathlete for the next round of the Olympics? No, they don't have such a thing. Okay. Now, the next examples are a little spicier, okay? We have here 0 is less than 3x plus 6 to the -1st is less than 1/3. So remember, this -1 exponent means the same as 1 over 3x plus 6 is less than 1/3. Now, unlike equations, if there are variables in the denominator, you are not allowed to multiply through by the LCD. I'm going to repeat that again. Inequalities are different than equations. If you have variables in the denominator, you are not allowed to multiply through by the LCD and clear them out. So sorry. So you might say, what in the world am I supposed to do? Well, this is a compound inequality. I'm going to split it up into 2 and work on them separately, okay? So if I have 1 over 3x plus 6 is greater than 0. I'm going to write that separately. 1 over 3x plus 6 is greater than 0. And at the same time, 1 over 3x plus 6 needs to be less than 1/3. So let's work on each piece by piece. Look at this first one here. 1 over 3x plus 6 has to be greater than 0. I know 1 is not negative. So in order for this whole expression to be greater than 0, it really depends on 3x plus 6 being greater than 0. So solving that inequality is equivalent to just solving where 3x plus 6 is greater than 0. It means the same thing because I can tell the numerator's already positive. Okay, we can solve this, no big deal. That means 3x would be greater than -6 and x would be greater than -2. Okay. And at the same time, 1 over 3x plus 6 has to be less than 1/3. Now, I can take the reciprocal of both sides of the inequality, but I have to flip the direction of the inequality. Why, you might say? Okay, let's go back to our example. 2 is less than 100. We know that. If I take the reciprocal, 1/2, 1 over 100. Now, which quantity is bigger? 1/2, right? I'd rather have half a donut than 1/100th of a donut. Come on. So same idea here. If I take the reciprocal of both sides, then you're going to have to switch the direction of the inequality. So now we have 3x plus 6 is greater than 3. And that means 3x is greater than -3 if I subtract 6. And x is greater than -1. So we've got two statements here that need to simultaneously be true. X is greater than -2 and x is greater than -1. This is tricky to understand without graphing. So here's our number line. Here's -2. Here's -1. X greater than -2 means you would have an open circle and shade this way. And so at the same time, x needs to be greater than -1. So you would have an open circle here and shade to the right. Really, this inequality, x greater than -1, is a subset of the inequality x greater than -2. So the only place where both inequalities are going to be satisfied is right here, people, from -1 to infinity on that interval. And if you were to write your answer in set builder notation, you don't need to put both intervals, because if you say x greater than -1, you're already taking care of, the other scenario. And you can't have these values in here. No, those are not included in the solution because they don't satisfy the second inequality, x greater than -1. So your final answer is right here. Okay, I know that one was tricky. Okay, last two. Just fun little exercise. So find A and B. They give us an inequality here. -4 is less than x is less than 0. Then A is less than 1/2 x is less than B. So I'm just going to play around with this inequality that's given to match the one that includes A and B so we can figure out what those values are. So I'm just going to write out -4 less than x less than 0. And it looks like they just multiplied through by 1/2, right? So let's do it. 1/2, 1/2. So -4 times 1/2, that's going to be -2, is less than 1/2 x is less than 1/2 times 0, 0. And now we're done. This must be A, this must be B. Did you expect it to be harder after the last one we did, huh? Okay, that was a cakewalk. Next one, wee bit more tricky. So we've got x's between 2 and 4. Then A is less than 1 over x minus 6 is less than B. So first I'm actually going to subtract 6 from everything in this inequality, and then I'm going to take the reciprocal, okay? So to start off, I'm going to have 2 minus 6 is less than x minus 6 is less than 4 minus 6, right? So -4 less than x minus 6 less than -2. Now I'm going to take the reciprocal. So I want 1 over x minus 6, negative 1 over 4, negative 1 over 2. But remember, we have to flip the direction of the inequality when we do that. Bam. So this matches the structure of the inequality that they gave me, but notice since the way I have it written, the inequalities are the other way around. That means A and B are on opposite sides. So if you want to rewrite it, you can. This is the same as negative 1/2 is less than 1 over x minus 6 is less than negative 1/4. And then maybe now it makes more sense to your brain too, right? This is the bigger quantity than this. So that means A is negative 1/2. This is A, and then this is B. So A is negative 1/2, and B is negative 1/4. That's it. So, hope you like those little exercises. They're just a little different, you know? And then coming up next, we've got solving equations and inequalities with absolute value. Ooh la la. So stay tuned, give the video a thumbs up, subscribe if you haven't already, and I'll talk to you guys later.